Hello everyone, we are Group G4 from the Bilingual Mechanical Engineering degree, and we are going to explain you how to compute the reactions and how to draw the diagrams of this portal frame. In this particular case of portal frame, we have one torsional spring support, one internal hinge, and one roller support. And we have two punctual loads and one punctual moment on the hinge. So we were asked to design an aesthetically determinate system. So first of all, I'm going to show you that this is aesthetically determinate. For that, I'm going to use the formula of the indeterminacy degree. The indeterminacy degree of the internal part of the structure is 0, and of external part is calculated by this formula. So R is the number of total reactions of the system. So on the torsional spring we have 3 reactions. One is the reaction of the vertical axis, the reaction of the horizontal axis, and the reaction of the moment on A. And the other reaction is on C, on the roller support, and it has only the vertical reaction. So we have 4 reactions, minus 3, minus A0, that is this hinge, 1. So it gives 0. This is because it is an aesthetically determinate rigid joint structure. So now I'm going to compute the reactions. First, the summatory of forces of the x-axis must be 0. So we have the reaction of A on the x-axis, AX, minus this punctual load should be equal 0, and we have that the P equals 5 kilonewtons, so AX equals 5 kilonewtons. Now, the summatory of forces of the y-axis should be 0, 2. AY minus P plus CY equals 0. As before, P equals 5 kilonewtons. We will take moments on A, so the summatory of moments on A should be equal 0. We have the reaction of the moment on A minus the moment created by this punctual load, which is P, times the distance from P to A, which is L force, plus M, this is the punctual moment on the hinge, plus Cy times the distance from C to A, which is L halves plus L halves, L, minus the moment created by this punctual load, which is P, times this distance, L halves, equals 0. And finally we have the equation from the hinge. I will take the left part of the hinge because it's easier than the right part. we draw the punctual load and the punctual moment, and the reactions on the torsional spring support. MA, AY, AX. So we know that the summatory of moments on the hinge must be 0. So we do the summatory. M plus this distance, which is L force, P times the distance, A plus the reaction moment MA minus AY times the distance, which is L force plus L force, L halves, equals 0. So we have now 3 equations with 3 unknowns, and we can solve the system. And substituting the values of the L, M and P. So I have solved the system, and the reactions are AY 0, CY 5 kilonewtons, and NA minus 15 kilonewtons meter. And we have the 4 reactions of the system.